reason to explain the law of logic from topic 2. So this is one of the methods to prove the logically equivalence of primitive preposition, logically implies of primitive preposition, or to prove the statement is tautology or contradiction. So this is the list of law of logic.
So the first question is we have to prove that P implies R or Q implies R logically equivalent to P and Q implies R. So the first step is to change the implication using definition of implication, and you get negation P or R or negation Q or R. Since it's become the same symbol, we can move the item around. So we combine negation P or negation Q together and R together. And then we will use idempotent law for R. And then we can negate back the negation, and we will get negation in bracket P and Q, and then or R. Now we can change back by using the definition of implication, and we get P and Q implies R. So we have proven that P implies R or Q implies R logically equivalent to P and Q implies R. This next question is an example of tautology question. And this is an example for simplified question.
Argument is a list of a given statement called premises followed by the final statement called conclusion of the argument. Premises from the hypothesis of the argument and the conclusion can be expressed as above. Define the premises and show the conclusion follows logically from the premises. Use implication. An argument is valid if each premises and conclusion is true. To prove validity of the argument is by showing implication is tautology. Rules of inference is a technique used to avoid large truth tables. Arise from a logical implication. It has 13 rules. Second, we have law of logic. Law of logic is used for any primitive proposition, PQR, any tautology, and any contradiction. That's rules. Lastly, we have truth table. It is used to display the relationship between the truth value of proposition. It is not practical to determine validity of argument, including more than 3 propositions.
Let's look at the example. Determine whether the argument below is valid. If Salma studies hard, then she passes the exam. If Salma does not play computer games, then she studies hard. Salma failed the exam. Therefore, Salma play computer games. From the question, we know that we have to determine whether the statement is valid or not. Now that we know what the question wants, let's look at the statement. First, we have to divide the statement into several different parts. Number 1, we have Salma studies hard, which can be labeled as P. Number 2, she passes the exam, which can be labeled as Q. And number 3, Salma plays computer games, which can be labeled as R. Next, let's look at the statement again. For the first sentence, if Salma studies hard, then she passes the exam, which can be concluded as if P, then Q, which means P implies Q. For the second sentence, if Salma does not play computer game, then she studies hard, which can be concluded as if negation R, then P, which mean negation R implies P. And for the third sentence, we have Salma failed the exam, which can be concluded as negation Q. And for the fourth sentence, which is the conclusion, therefore, Salma plays computer games. Now, from the discoveries in the statement, we can conclude that P implies Q and negation R implies P and negation Q implies R. These are the solution. These are the solution. Here are other question examples. Here are other question examples.
For topic
Here-
3, we have chosen choose method and specialization. So I'm going to explain about choose method. For choose method is used when the statement in the backward process contain the universal quantifier for all. Such statement occur frequently in set theory. Set theory is a set is collection of objects. Each object in a set is called a member or element of the set. A set is denoted by enclosing the list of its member separated by commas in set brackets. For example, element of A is 2, 4, 6 and 8. Then 2 is element for A and 5 is not element of A because in set A we don't have number 5. Next, set which very large number of members or set with infinite members can be donated by using set builder notation.
Given A, which is S, x element of real number, x squared minus 3x plus 2 less than equal to 0. And T is x element of real number, x more or equal to 1 and x less or equal to 2. Then, given B is S subset T. In B1, we use backward process and it become for all x element of S, x element of T. In A1, we use choose method because in B1, it contains the universal quantifier which is for all. So, in A1, we choose among S and it become choose A element of S. And in B2, A element of T. In A2, we substitute A in S and it become A squared minus 3A plus 2 less than equal to 0. In A3, from A2, we factorize the equation that in A3, it become A minus 1, A minus 2 less than equal to 0. Next, we create a table which is contain interval, test value and side of A squared minus 3A plus 2 less than equal to 0. Next, we consider a negative sign of A squared minus 3A plus 2 because the equation is less than equal to 0. So, in A4, it becomes A element of 1, 2. Then, we can see that 1, 2 is same with A more or equal to 1 and A less than equal to 2. So, in A5, it become A element of T. So, it shows that A5 is equivalent to B2. 2. Given two sets, S and T defined as follows, use the choose method to prove that T subset S. So, this is how to use choose method to prove that T subset S. 2. another question. Given two sets S and T defined as follow, then prove that S subset T. So this is how to use choose method to prove that S subset T.
Definition: a real number U is an upper bound for a set a real number T if for all elements in T is less than or equal to 2. We use this method if a hypothesis contains quantifier for all. Apply specialization. First, assume A is true identity, the object certain property and something happened. 2. Search for one object to apply specialization, usually obtained from the backward process. 3. Verify that this particular object does have certain properties specified in A. 4. Conclude by a new statement in the forward process that this something happens.
For A subset B and B subset C. For B, A subset C. B1, for all X element A, X element C. A1, choose A element A. For B2, A element C. A2, for all B element A, B element B. For A3, for all C element B, C element C. A4, specialize A1 with A2. A5, A element B, so we get A6, A element C is equals to B2. Example 2, P subset Q, where G and H are functions. G is greater than or equal to H on Q. For B statement, G is greater or equal to H on P. For all elements P, element P, GP is greater or equal to HP. A1, choose an element other than P, X element P. Gx is greater or equal to Hx. For all elements P, element P, P element Q. A3, specializing A2 to X, X element Q. For all Q, element Q, GQ is greater than or equal to HQ. And lastly, specializing A4 to X, Gx is greater or equal to Hx, which is equals to B2. Example 3, R subset S and U is an upper bound for set S. U is an upper bound for set R. For B1, for all X element R, X is less than or equal to U. Choose A element R. A is less than or equal to U. A2, for all X element R, B element S. A3, for all C element S, C is less than or equal to U. Next, specialize A1 with A2. A is element S. A6, A is less than or equal to U, which is equals to B2.
For conclusion, to conclude for topic 2, there are techniques to prove the question is true or false. Logically equivalence, logically implies, tautology or contradiction. One of the techniques is by using laws of logic. In argument, we need to prove that the argument is valid. To prove the validity of the argument, we can use laws of logic, rules of inference, and truth table. This is also related to the knowledge laws of logic. Then, to conclude for topic 3, there are several methods to prove either the statement is true or false. To prove the statement, we can use choose method and specialization to know either the statement is true or false.